Okay, welcome to 2.4, Absolute Value in Open Sentences. The Common Core State Standard is Algebra 2 Standard 1.0. Students solve equations and inequalities involving absolute value. Please take a moment and copy this. You can pause it if you need to. Okay, so we're going to be talking about absolute values, obviously, here, and how they might show up in equations and inequalities. Anytime you see a problem start off as absolute value of u is equal to a, or absolute value of u is greater than a, or absolute value of u is less than a, you'll handle the problem the same way every time. Now we're assuming that u is an expression that contains the variable. So u itself might not be the variable, but it contains the variable. Okay, so it could be, for example, u could be like x plus 5 or something like that. But you're always going to handle it the same way. You're going to break it down u is equal to a, or u is equal to negative a. And anytime you're running into one of these problems here, the second style, where absolute value is greater than a, you would break it down into u is greater than a, or u is less than negative a. Notice the opposite sign there. This is a less than and a negative. In the third case, you can split this into u is less than a and u is greater than negative a. And this last one is convenient because you can actually break it down into, that can be actually kind of consolidated into a combined inequality. Okay, and so also please remember that the u here is an expression involving x. So let's make a note of that, where u is an expression involving your variable. So involving the variable you are trying to isolate. Okay? Let's look at some examples. Okay, the first example is solve the absolute value of 3x minus 2 is equal to 8. Okay, this is the expression I was telling you about u. Okay, and then this over here would be your a. So now we're dealing with an equality problem. There's an equals here. So you're going to be breaking this up according to the first pattern. So let's go back and look at that real quick. So it says here that if you're going to be dealing with an equals a, you're going to be splitting it into two equalities. One uses a and the other uses negative a. So we are going to write u is equal to a, which is just 3x minus 2 equals 8. Then we have to write the word or, and then u is equal to negative a. Okay, so there's our setup. So what's happened is we've turned this into two problems to solve. They're both very simple. This one gives us 3x equals 10. And dividing, we get 10/3. Our other one is also involving adding 2, which gives us 3x equals -6. And dividing by 3, sorry about that, gives us x equals -2. Okay, so our answers are, if we put it in set notation, -2 and 10/3. Okay, let's look at another example. Okay, as you can see, this one is also an absolute value problem. It's an inequality, and it's a less than. So this is a less than problem, and those are to be solved according to the pattern on the previous page. So let's go back and look at that. Let you copy it there. Okay, ready? Okay. Alright, so here was our explanation of less than. It's this third one. You're going to take u is less than a, and u is greater than or equal to -a. Okay, so let's go back to our problem. This is our u, and this is our a. We're supposed to do u is less than a, and u is greater than -a. Okay, so it's going to be 3 minus 2x is less than 5. Notice that this looks just like the original problem, just without the absolute values on it. And this one over here is going to be 3 minus 2x is greater than -5. Okay, you might want to stop for just a second and look at these two expressions we just wrote, these two inequalities we just wrote. We're going to solve them both. But look at them and look what is the same and what is the different. Look at what's the same and what's different between them. Okay, let's go ahead and solve them. So for this one, we'll subtract 3 from each side. We get -2x is less than 2. We divide by -2. Don't forget to flip your inequality. Okay, so I just colored it to remind you. Okay, and then this one, subtract 3. We get -2x is greater than -8. And we divide by -2. And we get x is less than 4. Okay, this is an and this is just something you have to keep in mind. When to put the and when to put the or. And remember, with and we can make the convenient double less than, the x in the middle. Just make sure you put the small number on the left and the large number on the right. Okay, let's look at another example. And of course, we need to do one with a greater than. Okay, so without going back to the first page, you can if you like. Let's just go ahead and write down what our u is and what our a is. So this is our u. Oops. This is our u, and this is our a, and we're doing a greater than. Okay, so we'll go ahead and write it down as 2x minus 3 is greater than 7. This looks exactly like the original problem without the absolute value bars. Then we're going to need to write or, and for our second one, 2x minus 3. And can you figure out what you're going to write there? Okay, you should have said less than -7. and then these both need to be solved. Okay, so let's start in on that. Add the 3. 2x is greater than 10. Divide by 2, and we don't have to flip the sign around here because we're dividing by a positive. X is greater than 5. The word or is appropriate here. Let's solve the second one. X is less than negative 2. Please don't try to combine these two into one inequality. We don't do that with the or statements. And we have one more example. Okay, so you might wonder why we even need a last example. We've already done an equality, a less than, and a greater than. But here's the thing. The rules we've used for today, the U and the A rules, they really only work when the absolute value is isolated. You notice that the rules on the front page did not say something like this. There was no term here. So the rules are, we have to have the absolute value isolated before we can start a problem. Okay, so this is obviously not the example we're doing. But you can see how this one has this extra 3 located right here. Okay, so let me erase what I've got here. Okay, so it's very, very important that the first thing we do is move this over by subtracting 3 from both sides. Once the absolute value is isolated, absolute value of 2z minus 1 is greater than or equal to 5, then you can apply the rule. So we can see that this is a U is greater than or equal to A type problem. So we're going to break this up into 2z minus 1 is greater than or equal to 5, or 2z minus 1 is what? Less than or equal to negative 5. And solve. Okay, so this gives us z is greater than or equal to 3. Okay, let's go over and solve this one. Or, and then z is less than or equal to 2. Okay, so I just want to do one last little thing, and that's go back and put our answers in set notation. Okay, so I would like to go ahead and put this as the way the book does it. They declare the variable and put a colon. So the variable for this problem is z, and then they write the two answers. You should know how to pronounce this. This is z, such that z is less than or equal to 2, or z is greater than or equal to 3. So this is pronounced z such that. Okay, let's go back to example 3 and put that in. So this would be what? The set of all x values such that, and then you put our answer, x is greater than 5, or x is less than negative 2, one more. The set of all x values such that x is greater than 1. Actually, we'll go ahead and put it in the combined inequality form. Negative 1 is less than x is less than 4. And there you have it. Please take a moment and write down any questions you might have about tonight's video so that you can go ahead and ask those in class tomorrow.